everybody, welcome back to another Miss Pollard Math YouTube video. Today we're going to be going over interval notation, specifically for solving inequalities. We'll see that there's interval notation for our increasing, decreasing, when our f of x is greater than 0, less than 0, but that's a whole different topic. I have a whole other YouTube video on that. So this interval notation specifically for our foundational skills of when we are working with our inequalities. So let's take a look at the key details to know how we would appropriately solve these problems. So first, we have to know why we are doing interval notation. So interval notation is used to write the set of the real numbers that are included within this portion of our graph. So we're writing the set of all real numbers between two endpoints. So I'm trying to see on my number line or on my inequality what numbers are included in my solution set. So we're going to write that in an interval notation way to be able to see which solutions are there. To accomplish this, we want to find the solution sets for the inequalities, like I said, and we're going to be doing the domains and ranges of functions at times. We can use interval notation for it. So for a closed interval, that's when we use a bracket. So that's when we see like x is greater than or equal to a number, or x is less than or equal to another. So if there's a closed circle on your inequality graph, or it's an or equal to, you should know that you should be using a bracket. It's an open interval when we have parentheses. So when it's less than or greater than, we're going to use parentheses because it's not including that number. It's including all of those real numbers leading up to that number. We're going to use infinity. So infinity always has parentheses. We don't know what infinity is. We don't know what negative infinity is. So we can't use a closed interval because that's just some abstract big number, right? So we're going to have to leave it as a parenthesis. It denotes it's going on forever. This is also when you see arrows on our inequality graph. When we see arrows, that's when we know we're going to be using infinities. So let's try this problem for an or statement. So we are having x is less than negative 3 or x is greater than or equal to 2. And we want to put this in inequality graph, and then we're going to put it in interval notation. You don't have to make the graph per se. I think it's easier to visualize it, but you can think, I want all numbers less than negative 3, all numbers greater than or equal to 2, and create your interval notation. As you get more advanced, you can just do it like that. I suggest creating the graph so you can visualize it, but that's up to you. So for the graph, this is what it looks like. We have an open circle on negative 3 because it's not or equal to. We have a closed circle on 2 because it's or equal to. And we're going to create our interval notation from here. So what I'm going to do is, look, I have an arrow, and that arrow is going towards negative infinity, right? We're going smaller and smaller and smaller until we reach negative infinity. So we go from smallest to biggest. So we're going from negative infinity. The arrow denotes negative infinity. So I'm going from negative infinity. I'm going all the way up to negative 3. Because it's an open circle, it's just a less than symbol, I have to put a parenthesis. Then we are having a huge gap, right? We're having this big portion here missing. Well, I need to connect them. So we connect it with a U. U means union. We're unioning our two interval notations together to say this is our solution set. So I put a U, I like to say whoop. Then we have a 2. It's a closed circle because it's or equal to, so I use a bracket or closed interval, and we're going on forever. The arrow means forever. Well, anytime we see an arrow, that means it's infinity, and we're going to positive infinity. And if we look, we're going from smallest to biggest. Negative infinity is the smallest, to negative 3. We connect the 2. 2 is next, all the way to infinity. So this is how you do a interval notation for an or statement. We're now going to look at when we have an and statement. So now we have this and statement, which I like to call it the sandwich inequality. It's our inequality notation, but I call it a sandwich because they're connected together. So we have this interval notation that we need to find given this inequality notation. So once again, I'm going to graph it, but you might not have to graph it. I think and statements, you could just look at it and do it. However, if you want to see it on an inequality number line, that would be best so you can visualize what's occurring. So if you need help with that, this is what it would look like. We're going from negative 2, it's a closed circle because it's or equal to. We're going to 4, which is an open circle. So if you didn't recall that an and statement goes towards each other, I would graph it so you can see it to include your interval notation. If not, you might be able to just look at it and do it, like I said. But let's look at the graph. So if I look at the graph, or number line we're going to call it, my Lowest number is -2. -2 is a closed circle, so I'm going to put a bracket. Then I'm going. There's no jumps all the way to 4. 4 has an open circle, so it has a parenthesis. So for an and statement, you should only have the 2 numbers. You're never going to have the infinities. So we want to make sure that we're having just our 2 numbers for an and statement. I could just look at my inequality notation or that sandwiched answer and say we're going from -2 to 4, but if you need the graph, you may. So this was a quick little preview of how to do interval notation, and I hope it helped you with your and or statements.